In the previous video, we have been introduced to the classification of rocks, namely igneous rocks, sedimentary rocks, and metamorphic rocks. But have you ever wondered how each of them turns into a certain type of rock and how these three are related to each other? Well, that's what we're going to tackle in this video. Rocks change as a result of natural processes that taking place all the time. Most of the changes happen very slowly. Many happens beneath the Earth's surface, so we may not even see the changes. But although we may not see these changes, the physical and chemical properties of rocks are constantly changing in a natural and never-ending cycle called the rock cycle. It is simply the concept used to present how these three classifications of rocks formed and even converted into another type. This idea was first developed by James Hutton, an 18th century Scottish scientist often called the father of geology through his concept of uniformitarianism, which means the theory that changes in the Earth's crust during geological history have resulted from the action of continuous and uniform processes up until today. Though many of his ideas about the rock cycle were either vague or inaccurate, he made the important first step of putting diverse processes together into a simple coherent theory, which later on been delved and studied even deeper to lead to a more concrete explanation. Going back to the rock cycle, we should be reminded that this cycle has no beginning and no end, and we can start the process wherever we want. The key processes of rock cycle includes the crystallization. Magma cools either underground or on the surface and hardens into an igneous rock. As the magma cools, different crystals form at different temperatures undergoing crystallization. The rate of cooling determines how much time the crystals will have to form, and slow cooling produces larger crystals. Next is weathering, erosion, and sedimentation. In our previous topics, we've been already introduced to what these processes are. Weathering wears rocks at the Earth's surface down into smaller pieces. These smaller pieces or fragments are called sediments. These sediments were transported by running water, ice, and gravity from one place to another, or what we call the erosion. During sedimentation, the sediments are laid down or deposited, and in order to form a sedimentary rock, the accumulated sediment must become compacted and cemented together. Lastly, we have the metamorphism. This happens when rocks are subjected to intense heat and or pressure, usually over a long period of time. As rocks are exposed to these situations within the earth but does not melt, they become metamorphosed. This may change the mineral composition and the texture of the rock, and for that reason, a metamorphic rock may have a new mineral composition and or texture. So maybe you will ask, where is the rock cycle from all the information I've been presented? As rocks pass through one or more of these processes, they can transform into any other rock, creating the rock cycle. Let us take a look at the diagram to see how this works. Just like I said a while ago, we can start anywhere we like, but it is easier to start with magma. Magma is rock that is hot to the point of being entirely molten. Magma can either cool slowly within the crust, forming intrusive igneous rock, or erupt onto the surface and cool quickly, forming extrusive igneous rock. Intrusive igneous rock typically crystallizes at depths of hundreds of meters to tens of kilometers below the surface. To change its position in the rock cycle, intrusive igneous rock has to be uplifted and exposed by the erosion of the overlying rocks. Through the various plate tectonics-related processes of mountain building, all types of rocks are uplifted and exposed at the surface. Once exposed, they are weathered, both physically and chemically, and the weathering products, mostly small rock and mineral fragments, are eroded, transported, and then deposited as sediments. Transportation and deposition occur through the action of glaciers, streams, waves, wind, and other agents, and sediments are deposited in rivers, lakes, deserts, and the ocean. Unless they are re-eroded and moved along, sediments will eventually be buried by more sediments. at depths of hundreds of meters or more, they become compressed and cemented into sedimentary rock. Again, through various means, largely resulting from plate tectonic forces, different kinds of rocks are either uplifted to be re-eroded or buried deeper within the crust where they are heated up, squeezed, and changed into metamorphic rock. When these three types of rocks melt completely, they become magma once again, repeating the cycle continuously. Igneous rocks can be sedimentary rocks or metamorphic rocks. Sedimentary rocks can either be transformed into igneous rocks or metamorphic rocks. And metamorphic rocks can either become igneous rocks or sedimentary rocks. Now that we know how the rock cycle works, it is also essential for us to know why this is important. The rock cycle is the continuous succession of rock formation, erosion, and reformation. Its forces have shaped Earth's surface for 4.5 billion years. Its life-giving properties are powered by great convection currents in the mantle, causing crustal movements that form continents, mountain ranges, and ocean basins. With time, the Earth's crust has been altered, reformed, and eroded to form igneous, sedimentary, and metamorphic rocks. Early rock cycle. Earth's first rocks, which is the igneous rocks, cooled from a melt, forming two general rock types, the basalt and granite. Basalt is a dense iron-rich rock and forms the ocean floors, while granite is a less dense silicate-rich rock comprising the continents. Their gradual erosion released nutrients into the biosphere. The cycle is also important for the formation of soil. Earth's surface is in a slow but continual state of recycling, which ultimately creates soil. Meaning, without this cycle, soil formation wouldn't happen and there would be no plants or any other life. In minerals for life, movements of the Earth's crust release life-sustaining minerals such as sodium, iron, potassium, and calcium into the biosphere. Sodium and potassium are crucial for the nervous system, while calcium is an essential component for the synthesis of bones. It is also important for energy. The rock cycle is predictable and provides insights into the probable locations of energy sources. For example, fossil fuels are found in sedimentary environments, while radioactive elements for nuclear energy, which is the uranium, may be found in igneous or sedimentary environments. In building materials, rock cycle is responsible for creating different kinds of rocks and minerals such as iron, limestone, marble, granite, and basalt, which have been used for building materials for thousands of years as the structures depend on this. Lastly, it is important for gems and currency. Gold, diamonds, rubies, and emeralds have been and continue to be used as currency, investments, and adornments. Their discoveries were based on knowledge of Earth's processes and have played a key role in smooth transactions of inter-societal trading. And that's it. In this video, we learned about how the rock cycle works and its importance. Thank you for watching.